angiosperm trees for rural communities. So I'll try to explain what all these words are. Water filtration, you all know. We all want filtered water. Consumption is safe. Right? What is xylem? Have you heard about xylem? Anyone of you from biology or botany background? You are? You have heard about xylem? What is xylem? Yes, it's used for water transportation in trees. Right? And what is the gymnosperm trees? There are two types of, right? Gymnosperms and angiosperms. What is the gymnosperm? Louder? Which give? So, angiosperms are mostly trees which have big, huge flowers and which have fruits. They are called gymnosperms, right? For rural communities. And this work is being done by one of my students, Vasudev. He is in PhD and with other faculty colleagues at IIT. So, water or consumption of safe water is very important. This graph here shows like how many deaths occur every year because of unsafe drinking water. And India is at number 1 here. We don't want to be number 1 in this stats, right? And you'll be shocked to see that in India every year 3,38,000 people die because of lack of access to clean water. And this number is shockingly low in other countries. In Russia, it is just 131 deaths in 1 year. Although the population of Russia might be 10 times less than India, still this number is quite low. Canada, just 64 people die every year. So this situation is very grave in India. And talking about some more stats, in world, 1 out of 4 people, they lack access to safe drinking water, and 1 out of every 5 newborn children, they die under the age of 5 years because of any waterborne disease, right? And there are several diseases. You might be aware about the different diseases that occur because of the consumption of unsafe water. But India is really a water-stressed country. 19% population doesn't have access to clean water. So the only solution to this problem can be development of decentralized filtration techniques. What is the meaning of decentralized? Decentralized means that at the source we can filter our water at our homes only. Right? Right now we follow centralized. Your water supply is being given by the government and that is being given to your houses using pipes or whatever it is, right? But there should be a decentralized filtration technique which is available to us, right? And we have them. Before going ahead, I did some data digging about the impact on Adivasis. And this industrialization, now many companies are moving into forest for rubber, for pulp, for different kind of resources which can be extracted from forests, right? So 50% of children in Odisha and 75% in Madhya Pradesh, they are affected by intestinal helminthiasis. It's a disease in which blood comes in the intestines. Also, we all have read the news of the breakout of waterborne disease in the tribal belt of Odisha in 2022, and the same happened in 2007. In 2007, 70 people died in tribal areas. In 2002, the number was around 8 deaths. Still, it is grave, right? So, the present status of household filtration is we use RO filters. I've seen out there are RO filters, but they are expensive, even though they are very effective, but they are expensive, right? This comes at the cost of around 14,000 rupees, and you need to change the candles, some other parts, RO system, of every maybe 1 or 2 years, depending on how the quality of water is in your area, right? The next technique is the gravity filters. They are not very expensive. It costs hardly 1,500 rupees or 1,800 rupees. Still expensive for some communities, but they are not very effective. The pore size is not very small, that it can do ultra filtration. And the third one, which is mostly used in areas where there are slums or where they don't have access to very good financial conditions, they sometimes use these particle filters. Just a cloth is kept on the top of any vessel and they filter it, right? it is not at all effective because the pore size is sometimes ranging from 500 micrometers, right? So when you choose a filter, the cost, maintenance cost, and access to electricity, it plays a very important role when you choose a filter, right? And the people, so these pictures are taken from the slum areas near Beas. I'm from Mandi, and we have a river Beas flowing from there. We want there's a these kind of filters for these people. So these pictures are being taken in the slum areas. They don't have filters there, right? So how can we develop decentralized systems which are accessible and inexpensive, so that the people they can use it readily and without having a much cost to their pocket? So that is the main motive of this work was, you all have seen trees. Trees, they transport water. From where? From the soil to the atmosphere, taking water from roots and transporting it to the transport tissues, then transpiration occurs at the leaves, right? Now these trees, they are very tall, sometimes going up to like 70 meters, 60 meters, right? So this is all about learning from nature. In the trees, if you see the trunk of the trees, we have the outer bark, the pit, and then the xylem tissues. These are the transport tissues which transport water, all because of the negative pressure which is being generated because of the transpiration at the leaves, right? And if you see the structure of the xylem, it is like this. We have vertical tubes, and these tubes are closed at the ends, but they have small pits or holes. So the water transport, it occurs through this blue path I have shown here. It starts from one tube, then from the pits it's being transferred to the other tube, and then successively the filtration occurs. Now these pits, if we try to see the magnified view of these pits, yeah. So this is the magnified view of the pit. It has got fibrous membranes, right? And talking about size, do you know how much is 1 micrometer? 10 to the power minus 6. You know what is the thickness of our hair? Anyone? Random guess? It is 160 micrometers on average, depending on nutrition of a body, but it is around 160, 150 micrometers. The size of this picture, this scale is 1 micrometer. Imagine how small it is. So water is being transported from these vertical tubes, and between these vertical tubes from these pits. Now this has got a fibrous membrane. Any contaminant, it can be trapped in these fibrous membranes. It means that we have got a potential for filtration here. Right? Very simple filters. Just cut a stem, right? Peel off the outer region, fix that portion into the pipe, switch on the pipe. You will get a filtered water, and the size of this porous membrane is of the order of 1 micrometer. It means that any foreign object which is greater than 1 micrometer, it can be trapped in these fibrous membranes, thus making water fit for consumption. Now let us see what kind of contaminants we can have in water.
Good morning, madam. Good morning. Madam, this is Rudra last
Might affect your health. There might be